Okay, welcome to the second day of vectors. Today we're going to find the magnitude and direction of vector, and at the very end we're just going to list some extra definitions of special vectors. All right, let's get on it. So here's your warm-up. Again, pause now. Okay, pause now. If you would like to work it on your own, strongly suggested to do that. Make this just a little smaller for now. You don't need it. All right, I'll come back to you in a minute. All right, so after you worked out the warm-up, here it is. So let the vector v have an initial point at -3, -5, and a terminal point at -7, -3. Determine the components of vector v. So this is acting for the vector that is in the brackets, right? So we have to remember yesterday we did x's first, and it's the second x minus the first x, so that's -7 minus -3. Now watch those signs. Okay, -7 minus -3 will end up being -7 plus 3, which is -4. Okay. Then our y's, we will have the second one, -3 minus -5. So again, a double negative. So it'll be -3 plus 5, which is going to be 2. So the answer to number 1 is -4, 2. All right. Says P is 2, -1, and Q is 7, 3. We know those are points because they have parentheses. Okay, points because they have parentheses. We're doing the same thing with different numbers. So, second x, which is 7, minus 2. Okay. 7 minus 2, which is 5. And then our next one, which will be 3 minus -1. Again, a minus is a plus. That is 5, 4. That is the answer to number 2. All right, and last we have a challenge. P is 4, 5, the point, and Q is x, y. Vector V is PQ 1, 1. Okay, what are the values of point Q? So we know we would take the second x and subtract 4, right? And whatever we get from that, we should get 1. So what minus 4 is 1? Well, x would have to be 5. And then we do the same thing with our y's by logic. We would have y minus 5. And what minus 5 would give us our other 1. So we would know that y equals 6. So our answer is Q, the point with parentheses, is 5, 6. Does that make sense? And notice, I know Q is a point, not a vector, because I wrote it with smooth parentheses. Onwards to notes. All right, so what do you think the magnitude of a vector means? Okay, so hopefully you thought about it a little yesterday. Magnitude is just the length. So that's going to mean it's going to break down if it's just length, okay? Here's our definition. Magnitude, length of a vector, okay? And then if it's length, that means it's just going to be a single number value again, which is what we've dealt with for years, okay? Next, we also have to question ask is, what is the direction of a vector? So this definition would be direction is the angle it makes with the x-axis measured counterclockwise, and this is very essential, in degrees, okay? It can also be written with the compass directions north, south, east, and west, right? North, south, here's west, here's east, and we'll talk about that more in our next section. All right, so we are actually going to find the length. Take a moment down to write down this formula. It is so important to write it down so that way you know that you have it. All right, it has 2 steps. Before we can use the formula, it needs to be in component form, okay? Has to be in component form. So when they give us 2 points, we need to make it into vector v first. Then we can put our points into the formula, okay? So our example is find the magnitude of vector v that has initial point -2, 3 and terminal point -7, 9. So what I will do first, since they're giving me point P and point Q, and I need to find V, right? So that means I will be taking my P with the X, so I will have -2, ooh, should I go that way? Nope. -7, sorry, terminal point first, minus -2, okay? So it's always terminal minus the other, so -7 minus 2 is -5, okay? And then I will take my 9 and I will subtract 3 for my y's. So that's just what we did on the warm-up. That's just what we did yesterday. So my vector is -5, 6. So once I have that done, I'm going to use my formula it has given me. Okay? And my formula is the square root of v1, this is v1, squared. So v1 squared would be that, and I will put plus the v2, and this is v2, and it will be squared. So I'm just going to plug in my components there. So I'll have -5 here and 6 here. Okay? You can either do this in pieces, but it's very important that when you use a calculator, okay, which a lot of you like to use, if you type this in the calculator, sorry, you have to fight with the calculator, you can use the scientific mode on Desmos just fine. Just make sure you're using parentheses carefully. So square root, okay, parentheses, -5, close parentheses, squared, plus parentheses, 6, close parentheses, squared. The in-person calculators will work the same, except they will have an extra parentheses written in them themselves for the square root because they're not as fancy. Of course, you can always use Desmos instead. And you hit enter. Oop, that's not necessary. A little taller. All right, so we get the answer equals 7.8102496676. Do you think I need all of this? No, in this class, I will only be asking you for the first 2 decimal places. So my answer would be 7.81. The magnitude of that vector is 7.81. Sometimes you do end up with whole numbers, and that's nice, but not terribly common. All right, so at this time, you would go through and look at your worksheet, okay? And you've got 10 problems to do. Make sure you're doing the second one minus the first one, okay? So hint you should get for your first one, okay? 1, 3. Yes, it is that simple. And your answer, okay, should be the magnitude of v, which is written like that. We talked about that a little yesterday in the notes. Okay, and if you do it right, you should get 3.16, okay? So take a time, pause this video, go through 1 through 10, try your best. Some of them have some funky answers, some of them have some tidy answers. Don't read too much into it, just follow the math. All right, now here comes for something fun. We are going to do direction. Now, if you go back and look at those notes, direction has 3 parts, okay? It is the angle the vector makes, okay, counterclockwise from the x-axis. So it's very important that you pay close attention to what I'm doing here, okay? First of all, you have to find it in component form, okay? Must be component form. Secondly, you're going to use the above formula. I suggest you write the entire thing I have written, or you might be sad. Okay, so take time to do that now. Okay, the key that we will be typing is we want to know the angle, right? We want to know the angle, so this is our essential formula here. Angle, okay? And it will be tangent inverse of V2 over V1, which is also known as Y over X. Okay? So, now what is tangent? Some of y'all might remember sometime in your lives doing trig functions. The good news is, look, here we have it on this calculator. Now the key here is twofold. Okay, I hope everyone's looking. It says main, ABC, and functions, and then right here has a little slider. It says rad or degree. Make sure it's on degree mode. If it's not in degree mode, it won't work, and you will be very, very sad. Okay, because we're not working in radians, we're going to be working in degrees. All right, next we need to find, this is tangent inverse. I don't see tangent inverse, so I'm going to go over to func. Okay, there it is. Okay, so when you have to do this, you have to hit func for function. All right, let's look at example 1. The work I expect you to show when you do this, okay, is I expect you to write what you type in the calculator. Okay, so I expect you to write, okay, I know I'm finding direction. So in the calculator, I will be typing tangent inverse parentheses y over x. So that will be 5 over 2 close parentheses. So over here, I will type from my func, tangent inverse 5 divided by 2 close parentheses. And the answer we get is 68.198. But remember, I said in this class I want 2 decimal places. But does that 8 round up that 9? Yes. Does the 9 would then round up this 1? So my answer, okay, should be 68.20 degrees. Okay, 68.20 degrees. So if you want to try for a second to do example 2 on your own, it is not different, but it does have a funky ending. Okay? So again, we have our x and our y. We will be using tangent inverse of our y over x. We will be typing that into the calculator. Okay. And we get it done, and it gives us the answer. Ooh, I messed up my parentheses. Y'all see that? All right, make sure your parentheses are working out how they're supposed to as you wrote them. All right, there we go. And we get the beautiful answer. Negative 36.87. Have y'all ever heard of a negative degree? A negative angle. I want you to try and imagine a negative angle. Yeah, that's not a thing. So we have to do an additional bit to this. Okay? So here's our additional bit. Let me shrink my calculator. We are done using it. All right, here's our additional bit. What you want to do when you're finding direction is it's in relationship to the x-axis, right? So if I were to roughly sketch where this is on my graph here, okay, negative 8 is somewhere over here. 1, 2, 3, 4, 5, 6, 7, 8. All right, and positive 6 is over here. 1, 2, 3, 4, 5, 6. So that means I'm over here. There's my angle, my vector, and here's my angle. Now my angle can't be negative 36. That doesn't make any sense, okay? So what we've got to review are that in our coordinate plane we have quadrants. In quadrant 1, which is where example 1 fell, the answer is just the answer, okay? But in quadrants 2 and 3, okay, you have to add 180 degrees to your answer to make it right. Okay, so when I have my answer over here, I'm going to add 180 to my negative 36. Okay, so just sticking that on there, so plus 180. Okay, which gives me the answer that is actually correct, 143.13 degrees. And that's the true answer to number 2. Okay, that's the true answer. Okay, and if you think about it logically, it makes a lot of sense. Y'all might remember that 90 degrees is a right angle, right? So that's 90 degrees. Well, my angle, that's in orange, is past 90 degrees. But it's not a full flat line, which would be 180 degrees. So we're somewhere between 90, well, that's 19, not 90. 90 degrees and 180 degrees. What's in between that? 143, which makes a lot of sense. Okay, our last quadrant, if you recall over here, okay, is quadrant IV for 4. Okay, and if you ever have a vector land in quadrant 4, you're going to be adding 360. All right, work on this for a minute. I want you to try, okay, try on your own for a second, 11 through 14, okay, 11 through 14. You need to be trying to do all of it, and then I will help you with some of them so you make sure that you're making sense. So pause, try them, and I will go over some of them. All right, so in 11 we have vector V is 3, 3. Please note that I could not type these with proper symbolism. So these are not points, these are vectors. I just can't always make the computer do what I want it to. All right, so 11, we're going to have tangent inverse of y over x, which is 3 over 3. And if you do that, you have 45 degrees. Now, I know that's the final answer because when I graph my vector, starting at the origin, right 3, up 3, or in quadrant 1, which is our do nothing. And you are done, okay? It's when you get to problems like number 12, 13, and 14 that you have to care a little bit more. And to prove that 3 over 3 is 45, there you go. All right, so number 12, okay, last problem of the day. Okay, we're going to have tangent inverse of negative 4 over 3. Okay, when you do that, you get another weird negative thing, which is not possibly real, right? Come on. Right, so that's going to be negative 53.13. You're like, okay, that's not right. So let's graph him. So we're going right 3 and down 4, which puts us in quadrant 4. And in quadrant 4, we add 360. Okay, so this plus 360 will be the correct answer. Okay, which gives us 306.87 degrees, which is correct. Okay, again, remember it's the angle between the x-axis right there and your vector. So that's almost a full Pac-Man. Do you see the full Pac-Man? Okay, we're almost to a full circle, so the fact that it's 306 degrees makes cents. Okay, try your 13 and 14 and submit it on your Google Classroom. I will tell you if you got it right or wrong. And don't forget, we've got some special notes at the very end. Equivalent vectors. We're going to have equivalent vectors be the same magnitude and direction. Parallel vectors, same or exactly opposite direction. Zero vector, a vector of a magnitude of 0, and a vector with a magnitude of 1 is a unit vector. And we'll go over these more tomorrow. Good work.